let's walk through this test problem by problem. Okay, so what we want to do here is graph this quadratic and list the vertex and the axis of symmetry. So this is a quadratic in standard form. What can we tell just from looking at it? Well, it better open down, and it has a y-intercept of 2. When you have a quadratic in standard form, you find the axis of symmetry using negative b over 2a, right? So b is 8. Negative 8 over 2 times a. A is negative 4. So this is negative 8 over negative 8 equals 1. Our axis of symmetry equals 1. To find the vertex, and when I want this written as an equation of a line, this is a vertical line, x equals 1. To find the rest of the vertex, the y, we have to plug in 1. Negative 4, 1 squared, plus 8 times 1, plus 2. So this is negative 4 plus 8 plus 2 equals 6. So let's graph this thing. We're going to... And our vertex is 1, 6. So here's 1, 2, 3, 4, 5, 6. My y-intercept is 2, and I can reflect this because I know it's symmetric. And here, whoops, here is my quadratic. All right, pretty straightforward, this problem. Let's move on. Now it says, without graphing, find the vertex, the axis of symmetry, and the x and y intercepts. Well, first of all, this form of the quadratic is the intercept form, right? Where y equals a, x minus p, x minus q, which means my x-intercepts are negative 5 and 3. I want these written as coordinate points. X-intercept is where y is 0, right? Okay, when you have an intercept form, the vertex is found, or the axis of symmetry, let's try that. The axis of symmetry is found, p plus q over 2. It's right in the middle. Negative 5 plus 3 over 2. Negative 5 plus 3 is negative 2 over 2. My axis of symmetry, written as the equation of a line, is x equals negative 1. Let's plug it in to figure out what our vertex is. Y equals negative 3, negative 1 plus 5, negative 1 minus 3. Negative 3, negative 1 plus 5 is negative 4. And that's negative, whoops, that's negative 4. All right, this is negative 4. So 4 times 4 is 16, times 3 is 48. This should be a negative 48. Oops, I keep hitting the buttons. The vertex is negative 1, negative 48. Oops, my mistake. It's not a negative 48. It's just 48 because negative 1 plus 5 is a positive 4. All right, now my y-intercepts. Your y-intercepts are found by setting x equal to 0, right? So now if we come back and make x 0, y equals negative 3, 0 plus 5, 0 minus 3. Let's see what it is. Negative 3 times 5 times negative 3. So this should be 5 times 9, 45 positive. So our x-intercept written as a coordinate point, our y-intercept written as a coordinate point is when x is 0, 45. So we have to go back to know what form of the line we have in order to find some things that are easier, like the x-intercepts from the intercept form. But it's also go back to the basics. When you're finding a y-intercept, x equals 0. When you're finding an x-intercept, if you didn't know what to do, you set y equal to 0, and you should be able to find it. All right, so now we're doing the same thing here. This is called the vertex form. Y equals a x minus h squared minus 1, where k is my vertex. Okay? 2, negative 1 is my vertex. You just have to watch this negative sign right here. All right, well, if I know my vertex, then my axis of symmetry is the x part of that vertex, isn't it? All right, here's where I want to remember when I find the y-intercept, x is 0, and when I find the x-intercept, y is 0. So let's first find our y-intercepts. It's going to be y equals 3/4, 0 minus 2 squared minus 1. Well, negative 2 squared is 4, times 3/4 is 3, 3 minus 1 is 2. 0, 2. All right, my x-intercepts, I think fifth hour had a negative here. In that case, there were no x-intercepts on the graph. Any things you found when you set y equal to 0 were imaginary, so there were no x-intercepts. But eighth hour, we changed that to a positive. So let's set y equal to 0. So what we have to do is solve it as if it's a square root, folks. Add 1. Don't work so hard by trying to FOIL this thing. You solve it as if it's a square root. I'm going to multiply by 4/3. So this leads to 4/3 equals x minus 2 squared. Take the square root of both sides, positive and negative. So I have x minus 2 equals the positive and negative. Square root of 4 is 2. Square root of 3 is square root of 3. Well, I can't deal with something with a radical in the denominator, so first I'm going to fix this. I'm going to rationalize it. So plus or minus 2 times the square root of 3/3. Now I need to add 2 to both sides, so I tack this on the front. Positive 2 plus or minus 2 square root of 3/3. These are my x-intercepts. That's when y is 0. I would accept you writing 2 plus or minus 2 square root of 3/3, 0. That gives me 2 x-intercepts. Moving on. Factor completely. So what we found here, folks, was to treat this as a difference of squares. If we want, we can do a little bit of substitution. Let's call x squared y. This now becomes y squared minus 1, which is y minus 1, y plus 1. Let's substitute back in for x squared. X squared minus 1, x squared plus 1. This is never, ever, 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 ever factorable. Is that enough evers for you? But this is another difference of squares, which is x minus 1, x plus 1. And then this comes back down to x squared plus 1. All right, this next one I want to factor completely. The first thing I do every single time, folks, we said, what's our go-to? Factor out any common monomials, right? So I look at this. I think all I can do is take out a 2 right now. Let's try that. 9x squared plus 18x plus 8. All right, I can't take a 4 out. So let's do what we do when we have an a that's not 1. 9 times 8 equals 72. What factors of 72 add up to 18? What did we decide to do? All right. Well, as I played around on my calculator, I found out that 12 times 6 is 72. So we expand this middle term, don't we? Plus 12x plus 6x plus 8. Now we have to factor by grouping. All right, what's common over here? It looks like I can take a 3 and an x out, which leaves me with 3x plus 4. All right. over here I need to get the same. I'm going to call this plus 2. Yep, and I get 3x plus 4. Remember, when you're factoring by grouping, this is not counted twice. Basically, what I'm going to do is factor the 3x plus 4 term out of here. Don't forget my 2. When I pull the 3x plus 4 term out, what's left? 3x plus 2. That is how we factor number 5. Moving on. All right, this one wants us to factor and solve. So let's see what we need to do. Anytime we're factoring and anytime we're factoring and solving, we have to set it equal to 0. So let's subtract the x and the 8 over. So we have 12x squared plus 6x minus 6. All right, what can we factor out of this? We can at least factor out a 6, 2x squared plus x minus 1. All right, because I'm solving and not factoring, just leaving factors, I can divide both sides by 6. And now I have 2x squared plus x minus 1 equals 0. Well, a times c is negative 2. What factors of negative 2 add up to a positive 1? A positive 2, negative 1. Let's expand our middle term. Plus 2x minus 1x minus 1. All right. Factor by grouping, I can pull a 2x, and I have an x plus 1. Set negative 1 out, and I have an x plus 1. So now my factors are 2x minus 1, x plus 1. Set each factor equal to 0 and solve. I'm going to suggest that you do all the steps here, folks, because when we don't do the steps, we think we can do it in our head. We get them wrong. We make silly mistakes. So x equals 1/2, x equals negative 1. Okay? Number 7. Again, I got to get everything over to one side. So let's subtract an x from both sides. This becomes 4x squared minus 16x. Everybody way overthought this. What's our go-to first step every single time? Factor out any common monomial terms. Well, guess what? I can pull a 4x out of this, and I'm left with x minus 4. You guys, there are my two factors. 4x equals 0, so x equals 0. X minus 4, excuse me, let's write that a little neater. X minus 4 equals 0, x equals 4. Those are my x's right there. People way overthought this. It actually was supposed to be very simple. Moving on. We had a problem with these. These were supposed to be solve using square roots, folks. Square roots. And in that case, your job is to isolate the quantity that's squared. Right? So, first I'll add 18 to both sides. 7x minus 4 equals 28. I'll divide by 7. X minus 4 squared equals 4. All right, square root of both sides. X minus 4 equals the positive and negative square root of 4, which is positive and negative 2. Add 4. I always tack it on the front. 4 plus or minus 2. Well, in this case, I can actually figure out the answers. 4 plus 2 is 6. 4 minus 2 is 2. These weren't supposed to be that hard. Now, let's get everything to one side and see what we come up with. We're going to add 9p squared, and we're going to subtract 4. If we add 9 over here, we get 12p squared. If we subtract 4, what do we get? We get plus 3 equals 0. All right. Let's subtract 3 from both sides. 12p squared equals negative 3. P squared equals negative 3 over 12, which is negative 1/4. and we'll finish this one up in the next video.